All right, so the first thing is they have this picture and they say, Ken, is there any type of energy that you see in this picture? Now, we haven't even talked about energy, but I'm sure you guys know some types of energy, even if you don't think you do. Anybody see anything? I do see some kinetic energy. What type of kinetic energy?
The cat is chasing a a mouse.
Yes. So Leo and Eric said this cat chasing this toy mouse. That is kinetic energy, which is just energy of motion.
And the door burst open.
Yep, the door is opening. That's also kinetic energy. Anybody see anything else? What'd you say?
The sun.
Yes, the sun. That's definitely some energy. What type of energy do you think? What's the sun give us?
Solar energy. I don't know.
It gives us heat for sure. What else?
Wait, on the color window, is it classmates, I think?
Say again now?
What do I get for the window?
Oh, it's in there. Yeah, it's in there. So the sun gives us heat. Can somebody online tell me what else the sun would give us? What else is the sun good for?
Light.
Yes, light, absolutely. Okay. So the sun will give us heat and light. All right. And then what else will give us light in this room?
The lamp.
Electricity.
Yep. There's this lamp over here. All right. So he said the sun, the cat's moving, the lamp. What about this clock?
The clock is ticking.
The clock is ticking. What else do you think this clock is giving us?
Sound.
Sound.
Yes, very nice. Sound energy. Okay. There's a bunch of energies in here, but
Oh yeah, the books on that shelf and like that can they move because of the door.
very nice. This book, so Leo said these books have energy. And he probably doesn't even realize this yet, but these books have something we call potential energy as well. And it's because they're sitting at a certain height above something. All right, so here we go. There are two types of energy, kinetic and potential energy. All right, kinetic and potential energy. So I'm going to be trying to switch back and forth. Matter of fact, let's see. Eric, can we use your notes? Okay, so I'm going to switch back and forth. So you may see some writing on here because Eric may be writing. Let's put a note right here next to kinetic energy when we get ready to do the definition for that, okay? All right, so switch back. There we go. Okay, all right. So the first one is kinetic energy. So what I do want you to write for kinetic energy, that kinetic energy is energy of motion. Whoops, I did not do a good job of doing that. So let me erase this. And I did not do a good job for that. Kinetic energy is energy of motion. Energy of motion. I do want you to write that down, okay? So kinetic energy is energy of motion. You can write this whole thing if you want, but you can write energy of motion or energy in use. Everyone should be writing this down. Yes?
I'll write it.
Okay, kinetic energy is energy of motion. And if you want to shorthand it, now that we know this is kinetic energy, you can always write KE. Okay? KE is kinetic energy. And sometimes you will also see it as E, and then they put like a little K right here. Okay, this is also kinetic energy. So if you want to write that, so you know that anytime you see KE or E with a little K, that is all those are kinetic energy. Okay? All right, so anything that is moving has kinetic energy. Anything that's moving, okay? Now, this first is kinetic energy, and then what we're going to do is we're going to break it down. So it's like saying kinetic energy and potential energy are the countries. So now we're going to talk about the states within that country, okay? So we're going to start with kinetic energy. The rest of this is just saying basically the same thing over again. You don't have to write any of this, but any matter in motion has kinetic energy. There are many different forms of kinetic energy, and here are some examples of some of them, but we're going to write them again in just a second, okay? So you don't have to write these because they look a little twisted right here, okay? All right, so that's kinetic energy. All right, potential energy And you can come back and write this later if you want. You don't have to write it right now. But potential energy on your notes, so that would be, look how Eric wrote that right there. Perfect, okay? So potential energy, that's on this next one right here. If you want to write a note for that, potential energy is energy that is stored due to position or shape, okay? It's basically stored energy. So you can either write this whole thing, or if you think you're going to remember it, you can just say stored energy. Okay?
Should we copy that?
You should, anything that I'm highlighting in pink, you should write down.
Only the highlighted.
The part that I circle or square.
We shouldn't put like the title for it.
It's potential energy.
What about the kinetic
It's
energy?
potential energy. We already did kinetic energy.
Oh, it was, the title for that was,
Kinetic energy.
okay.
We're just taking notes. All right, so potential energy is stored energy. All right, and there are 4 types. You don't have to write them right now, but you can if you want to, okay? All right, so let's not write them right now, okay? All right, so that's what potential energy is. So now let's talk about the different types of kinetic energy. So I'm going to switch for a second to Eric's notebook, okay? We are now,
I was copying.
okay, give me a second. We are now going to talk about the 1, 2, 3, 4, 5 different types of kinetic energy. So I'm going to go through each type. You're going to write the type here. You're going to write a description. And then you're going to give an example. If you want to draw a picture, you can. If you don't want to, that's fine as well, okay? You get this, Leo?
Yeah.
All right. So now let's talk about the different types of kinetic energy, okay? All right. Here are your 5 types. You can write those in your boxes that I was just telling you about. So remember, we had these 5 boxes right here. Oops, let me make this a little bit smaller. So right here, these 5 boxes, you're going to write these 5. So one is mechanical, you got sound, light, heat or thermal, and electrical. So take a second, write those down. All right, so now that we have these 5 written down, we're going to talk about each one. So let's start with mechanical, okay? Or I'll come back to this. Don't worry about potential. Let's stay on kinetic for now. All right, here's mechanical motion. All right, mechanical motion is energy of motion, okay? Energy of motion. So let's write this down for the description, okay? Anything, you can write a ton of different stuff for the example. It really doesn't matter what you write because there's anything that's moving has mechanical motion. So it could be a car on the road. It could be a ball flying through the air. It could be somebody running, somebody swimming, somebody walking. It could be me twisting in my chair right now. It could be Eric writing. It could be Leo fixing his glasses and his hair. All of those are energy of motion. If it's moving, then it's mechanical, okay? So energy of motion is your description, all right? And then you need to write an example. You can do any example you would like to do, okay? So here are also, you have these examples. You also have these examples, someone swimming, a rocket, someone on skis, whatever you like to write, okay? And again, it is energy of motion. Energy of motion. Okay. All right. Now that we got that, let's move on to examples, or sorry, sound energy.
Oh, wait, the one example for energy of motion was.
Anything that you would like for energy of motion.
Please show it.
Can you tell me what are you doing right now?
Putting the information.
You're writing?
Yeah.
That's an example. You can write that down. That's fine.
Okay.
Anything that's moving. All right. sound energy. Ooh, I messed that up, didn't I? Sound energy, all right, is energy of moving, vibrating air particles. Okay, moving or vibrating air particles. Okay. So, for example, okay, I would like for you to do this. Okay, so it says moving or vibrating air particles. I would like for you to, everybody to do this at some, okay? Even if you're at home, I would like for you to put 2 or 3 fingers on your throat, okay, on your throat. 2 or 3 fingers on your throat, everybody, yes? Leo, did you put 2 or 3 fingers on your throat? Right here, like right on the little hard part, where if you're a guy, it might be like your Adam's apple, okay? Girls, it would be where a guy's Adam's apple is. And then I just want you to say something and tell me what it feels like. What does it feel like it's doing?
Vibrating.
It feels like it's vibrating. Yes, Eric. Feeling is mutual. All right, it is vibrating. That's exactly how sound works. So the more, even right now as I'm talking, I can literally feel the vibrations on my fingers, okay? So I may not yell at my parents. I might yell at Eric possibly, okay? Or music or echoes. Any of that is sound energy. Any of that is sound energy, okay? So you can put anything that you can hear, you can put that down for your example, okay? So go ahead and write down an example for sound energy.
Echoes?
Whatever you would like to write down, anything that you can hear is sound energy. All right, so now we got sound energy. Somebody said they were singing. Somebody said they put echoes. Somebody put that they were listening to music. Excellent. All right, let's go on to the next one. Light or radiant energy. Okay, light or radiant energy. This is energy of moving light particles, which are called photons, David, I did see your message. Sounds good. Okay. Light energy of moving light particles. Okay, they are called photons. All right. The other thing that I would
What does it mean
also
by-
like you to
What does it
write,
mean by vibrating particles?
vibrating.
Yeah.
Did you put your finger on your throat when I asked you to earlier?
No, yeah, but on photons, like,
It doesn't say vibrating. It just
no,
says
it
moving.
says energy created by vibrating particles that create waves.
Yes. So we can't see those particles. We can't see them,
Oh.
but they're moving through the air. Okay. So I do want you to also write this as a note, because if I talk about anything in terms of electromagnetic waves, we're talking about light energy. Okay.
Are there
So,
electromagnetic waves there
Mm-hmm.
on the there?
Yep, it's moving, right? Okay. So make sure you wrote energy of moving light particles, photons, and electromagnetic waves. Did you write both of these, Leo?
Oh wait, I'll put that too. Wait. Through space and time.
Look, anything that I put in the pink, that's what you should be writing.
Okay.
Yeah. Alrighty. So light radiant energy, there's tons of stuff I can think of for that. Gary, you got an example of some light energy?
Me?
Yeah.
The sun.
The sun, that's an excellent example of light energy. All right, so let's see what they put for some examples. You can put whatever you would like though. All right, so we got the sun, we got a light bulb, your phone screen, your TV screen, any of that stuff, anything that allows you to see light, okay? It also includes energy such as you were in my chemistry class, you would know this already. Electromagnetic spectrum, visible light, infrared, microwaves, radio waves, ultraviolet light, gamma rays, and X-rays, okay? I do also want you to make a note that it can be, okay, can be absorbed, transmitted, or reflected. Okay, I want you to also add that.
Oh,
Add a note somewhere. And I'll tell you why.
I need to put space.
That's fine. Okay, you can say it can be absorbed, transmitted, or reflected. For example, let's say it's summer,
What's transmitted?
go through. It means to go through.
Okay.
Pass through, kind of, okay? So for example, let's say it's summertime, okay? And let's say that it's really hot outside, okay? Would you rather be outside, if you gotta stay out there for a long time, in a black t-shirt or a white t-shirt? A what color? A white t-shirt. Very nice, because the white t-shirt is going to reflect a lot of your radiant energy, okay? While the black t-shirt is going to absorb a lot of your radiant energy, okay?
What do you mean by reflected?
Reflect means to bounce off.
So if you're wearing a white shirt, it will like glow in some way?
No, it just doesn't, it keeps you cooler because it doesn't go through as much through the white shirt and heat your body up.
Reflecting.
Yes, reflecting. Okay?
But isn't white like the only color that doesn't absorb, right?
I think they all have some level of absorption. It's just how high.
The light that we see from like a night, from the stars,
Mm-hmm.
the light is traveling like hundreds of years to get to us, right?
I am not a space science person, but yes, it takes a long
Yeah,
time.
I
to
heard
travel.
about that. Like,
Okay.
what if the moon the light is coming from years ago and now it's not from right now?
Oh,
That's what I'm thinking.
that's science for you. I mean, think about how far away the sun is and how we sweat in the summer. I mean, it's planets away. There's planets in between us and the sun, and it makes us sweat. Imagine if we were closer. All right, so that is light or radiant energy. Okay, light or radiant energy. All right, so here are some more examples of light or radiant energy. Remember, also I could use any of these, the radio, microwaves, infrared radiation is like when you turn on your TV using a remote control, okay? Visible light, ultraviolet, this is like the sun. This is why we wear sunscreen. Everyone should wear sunscreen regardless of what color.
What's infrared radiation?
Infrared is like how you turn on your TV,
Oh,
okay? X-rays, when we go to the dentist, we always put that big heavy vest on top of us so that our insides don't turn into mush, okay? All right, so that is radiant energy. Let's move on to heat or thermal energy. Heat or thermal energy. Okay. Heat or thermal energy. Energy from moving particles that produce heat. Okay. Heat from moving particles that produce heat. All right. Got all types of heat or thermal energy. Anything that has to do with cooking, a stove, an oven, some hot soup, your body heat. Anything that has to do kind of with temperature is thermal energy. So you have, here's some examples: hot soup, body heat, the oven. Okay, you also have, let's talk about what temperature really means, okay? All right, so basically, when they say that the thermal energy increases as temperature increases, what they really mean, so this says This is the moving particles or atoms, okay, that produce heat. Now, here's what really happens with heat, okay? You have these atoms, which is super tiny and you can't see them, okay? When they are moving fast, I do want you to write this down. When they are moving fast, they are bumping into each other. They're moving really, really fast, and that's when things are hot. Okay? And then as they slow down and they start to move slow, then what happens to the temperature is that it is actually cold. Okay? So we don't talk about it in this class that much, but what temperature actually means is how fast are the atoms moving? That's what temperature actually is. It's a measure of how fast or the average kinetic energy of atoms. That's actually the definition of temperature, the average kinetic energy of atoms. Okay? All right. So, did everyone write down fast means hot and slow means cold? Leo, did you write that down?
Yeah.
Okay, good.
The smoke, are the moving atoms there on the smoke?
Yep, they're in there too. They are all around us. Okay. All right. So let's go down. This is talking about the same that I just said. The faster they move, the greater the kinetic energy, which means the greater the thermal energy. Opposite is also true. Okay. It also depends on the number of particles. All right.
Yeah.
Okay. All right. This is another slide. I'm not going to worry about this because this atom does not look cool to me at all. Okay. All right. Leo, what do you think? Which one has more thermal energy, the hot chocolate or the ice water?
Hot chocolate.
Hot chocolate. Very nice. Particles are going to be moving way faster in here. Okay. And it's a higher temperature. All right. Here's your next one. Electrical energy. Electrical energy. Energy of moving electrons. Energy of moving electrons.
Oh wait, what was an example for thermal energy?
Anything that has to do with heat.
Okay.
You can put whatever you want for an example. All right. So electrical energy, you got anything that has to be plugged into a wall, that's electrical energy, right? So you can use whatever you want. Then you got lightning. It's all about the movement of electrons. Electrons are little particles that are inside of an atom. Okay, little particles inside of an atom. So energy of moving electrons. Energy of moving electrons. Okay. Hmm? All right. Energy of moving electrons. All right. So make sure you have an example down. That was your description. All right. Now we're going to switch back to potential energy. You should have something for everything. Okay. Something for everything, at least in the description and example box for everything for kinetic. Okay. All right. I'm going to scroll for a second so you can write down all of the potential energies. There's 4 different types. Let me just get there so you can see it. Oh, look at that. I landed right where they are. Here are your 4 different types of potential energy. So now we're on the next sheet that says potential energy. All right, gravitational, chemical, elastic, and nuclear. Leo, did you write these down?
Yep.
Got all four?
Do bananas have like radiation? I heard about that.
They do have one of these types of potential energy. Do you want to guess which one?
Nuclear,
No, not quite. Guess again.
chemical.
Yes, excellent.
Is it true that like if there's like a room with 100 people, there could be nuclear energy if they are there like for a long time?
Nuclear energy has to do with the nucleus of an atom. We usually think about nuclear power plants for that.
Yeah.
Or bombs, certain types of bombs. All right, gravitational, chemical, elastic, and nuclear. You should have those written down now. Okay. All right, here we go. Let's start with gravitational. Gravitational is sometimes called GPE, which stands for gravitational potential energy. Let me get to it. Almost there. All right, gravitational potential energy. This is energy stored in an object's position above ground. So really what it means is it depends on the height. Okay, you don't have to worry about the formula right now. You don't have to write that. Okay. All right. Energy storage. So anything that's not on the ground, anything that is not on the ground, that's sitting above the ground has gravitational potential energy. You can shorthand this and just say GPE. Okay. A lot of times we also take off the gravitational and just call it potential energy. And in that case, we just put E and then we put like a little P. Okay. So this is potential energy. That's a G, by the way. Sorry. G.
So that.
All right, here we go.
When you don't have your job.
All right, here we go. So, gravitational potential energy. Anything that is up. So, for an example, you could put anything that's sitting high. So, if I have a bottle of hand sanitizer sitting on my desk, it has the potential to fall and be moving. Okay, it has the potential to fall and be moving, which means it has potential energy. Okay. The higher up it is, the more potential energy. Okay. So, for an example, you could put, again, a book on a bookshelf, anything sitting on top of something, okay? Or anything.
Like that flag?
Yes, that flag. So Leo is looking at a flag in the room that's hanging up. It definitely has potential energy. It's hanging above the ground.
So gravitational is basically intent, like
It's basically gravitational potential energy is just energy that has the potential to change into kinetic.
Okay.
Yeah,
We took our school engineering.
I'm recording it too. Okay. So we just did the 4 different types of potential energy. Okay. All right, so that is potential. Here's my favorite type of energy, guys. is chemical energy. It is energy for multiple reasons. This is my favorite. It is energy that is stored in chemical bonds. Okay. All right. And as we break and make new bonds, we break some, we make new ones. We break some, we make new ones. Then some of that energy gets released. Why is this my favorite, you ask? Because I love food, and anything that you can eat has chemical energy. So any of your plants and vegetables and your food, all that stuff has energy to cause something else to happen, okay? Batteries and explosives are also examples of chemical energy, okay? This match, before he struck it, had chemical energy stored up. We were just waiting for it to be struck, okay? So make sure you get an example down, at least one example.
Strength.
Yes.
Not related to potential energy, but like the kinetic energy. Is this mechanical energy?
Yes, it's moving. Anything moving. Yep. All right, so that is chemical energy. All right, what we got next? Elastic maybe? All right, elastic potential energy. Energy stored in the stretch of an object. Stored in the stretch of an object. So anything that's kind of bouncy or stretchy, like when we talked about last time, those have like a tennis ball, right? That's bouncy and stuff, or spring, or a rubber band, or drawing back a bow. Those all have elastic potential
what?
energy. I'm sorry?
During what?
I'm sorry?
You said something about boat?
A bow, like a bow and arrow.
Oh,
Oh,
bow and
bow and
arrow,
arrow.
yes,
Oh.
a bow and arrow. Like this guy right here. This guy right here has a bow.
Oh.
He has a bow and arrow. And this guy, what's this called? Anybody know what this is? A slingshot. Ooh. Okay.
Where are the examples?
Anything that you can stretch. So this stretching a rubber band, drawing a bow is also an example. Springs, muscles, those are also examples. Oops, I'm going the wrong way. Sorry. Here we go. These are also a bouncy ball, a tennis ball, a rubber band. All of those are examples.
Oh. Okay. Let me.
Okay. You only need to write down one example if you want.
Oh, yeah.
All right. So you should now, at this point, you should have just one more box to fill in. And then we're going to talk a little bit and then we'll be done. Okay. All right. Actually, we're going to do some whiteboarding. All right. So here's the last one, nuclear energy. It is energy stored in the nucleus of an atom. Energy stored in the nucleus of an atom. Okay. Nucleus is like the very center of an atom.
The core?
The core, yes, excellent, Leo. The core of an atom. Okay. All right. Typically, when we talk about bonds and stuff, that has to do with the electrons, which is not the core of an atom. Which is not the core of an atom, but the outside of it. So when you start messing with the inside of an atom, it can be very, very dangerous. So this is like what happened with Chernobyl. Oh, maybe. What happened at Chernobyl, they lost control. It's very easy to lose control. When we have nuclear bombs, that is also nuclear energy. The sun, that's why the sun is so powerful, is nuclear energy. It's literally just little explosions going off over and over and over again. And it produces so much energy that even though it is, what, 2, 3 planets away? I can't remember. However many planets away, it can still give us light so that we can see and heat so that we can feel. That's crazy. You really think
does-
about how far the sun is and how much energy it has.
Does heat energy has something to do with the nuclear energy? Because there's atoms, right?
We're gonna talk about that. So Leo has led us into energy transformation. So right now you should have everything filled in pretty much, okay, for all of your different types. Okay, so let's talk about energy transformations and then we'll be done. Okay, so let me clear. All right, two things. One, energy, much like other stuff in science, cannot be blank or blank. Anybody know what that should be? Energy cannot be
The law of conservation. It
Law of
cannot be
conservation,
destroyed or
excellent.
created.
it cannot be
Destroyed or created.
created or destroyed. Exactly. Okay, you can't make it and you cannot get rid of it. It can, however, change types. It can change types though. Okay, so yes. So here are some examples of just different types of energy. Different types of energy. So for instance, this microwave, you got two things going on here, okay? It can be more than one thing. You have electromagnetic or radiant energy because it's a microwave, and you have thermal energy because it heats up your food. Mechanical energy right here because the plate inside of it moves, it spins around, okay? All right. When I look at this fan, one, it is electrical energy, very nice, because I have to plug it in for it to work. But once I plug it in, I turn it on, what happens? It turns into mechanical energy because then the fan is actually moving, okay? So I have electrical energy that transforms. It doesn't go away. I didn't create it, but it does turn into mechanical energy.
It turns into something else?
It turns into mechanical energy. Doesn't the fan move once you plug it up and turn it on?
Yeah.
Yes. So it turns into mechanical energy. All right, trick question. Let's see who gets this one. What type of energy does this tree have?
It has,
I can see that. Any guesses?
does it have chemical energy?
I definitely believe it has chemical energy. Some people will also argue and say it has gravitational potential energy, and I would agree with that. Well, that tree could fall over, okay? So I would take gravitational potential energy as well as chemical energy, all right? What type of energy is this?
I can't see.
It's right here, Leo.
Oh, it's because I'm watching it on my computer. Oh, heat energy?
Heat energy, very nice. What's the other word for heat?
Thermal.
Thermal, very
Light.
nice. Thermal energy. All right,
That's light too?
here's a tomato.
Gravitational energy?
If it's sitting on something, sure, but it's just a tomato right now.
Chemical energy.
Very nice, chemical energy. All right, great. Let's look at some energy transformations. We just talked about that, okay? So this is just saying that sometimes it transforms, okay? Especially when it comes to heat and light. That's easy transformations, okay? Batteries, wood, and matches, a lot of times it's chemical energy and then it converts into like heat and light, okay? Here's more examples. Plants using radiant energy. So plants use energy from the sun to convert it to chemical energy. So that's like photosynthesis. Okay, and then my favorite, chemical energy in food is then changed into another kind of chemical energy that your body can use, and then I can use that to move. So I can use that for kinetic energy. All right. Alarm clock, if it's plugged into the wall, it goes from electrical energy to light and sound. That's just some examples. Hair dryer, okay, I plug it into the wall and then it turns it on and the air comes out. That's mechanical energy. There's also thermal energy. It heats up so I can dry my hair, and sound energy, I can hear it. All right. So there's all types of energy confirmations. All right, so I'm going to stop sharing for just a second. And I'm also going to stop